Hi, welcome back to day 26 of online learning. Today we're going over Unit 7, Lesson 2.1. What I want us to do right now is I'm going to read this problem and then I want you to solve it by yourself. So it says, Mr. Lee's class is collecting pennies for a homeless shelter. On the first day, the third graders bring in 96 pennies. On the second day, they bring in 145 pennies. How much money do they have so far? So what I want you to do is take notes of this problem, write an equation, and solve it by yourself. So I'll pause you now, unpause me once you're done completing and solving this problem. What I need you to do first is I need to take notes of this problem. So it says, Mr. Lee's class is collecting pennies for a homeless shelter. On the first day, the third graders bring in 96 pennies. So first day, 96 pennies. On the second day, they bring in 145 pennies. Second day, 145 pennies. How much money do they have so far? So the question we're trying to figure out is, how much money do they have so far? So you could have solved this in a couple different ways. You could have either used it on a number line, you could have drawn a picture, but I want you to think about if I was going to do 90, I know that if they're asking all together, so how much money do they have so far all together, my equation would be 96 plus 145 equals what? What I want you to do now is I'm going to actually break down these numbers into hundreds, tens, and ones. So 96 would be 90 plus 6, and then 145 would be 100 plus 40 plus 5. So let's add my ones. If I did 5 plus 6, that would equal 11, and then 40 plus 90, 9 plus 4 is 13, so I know I'm going to have a 0, so 130, and then 100. But I know that since I have 11 here, that means that I have an extra 10. So I'm going to actually make this into 140. Because if I have an extra 10 here, I'm going to regroup that 10 and put it where I added my tens place, because this was my ones, my tens, and my hundreds. So now I have 1 plus 140 plus 100. So I know 100 plus 140 would be 240 plus 1 equals 241. So that means they have 241 pennies so far. Now let's think of this problem a different way. Let's say if I did my equation, so 96 plus 145 equals what? What if I did a 96 plus 4? What does 96 plus 4 equal? 96, 97, 98, 99, 100. And then I did 141 plus 100. And all I'm doing is focusing on the hundreds place. So that would be 241. So then I got my answer of 241 pennies. So I added 96 plus 4 because I took my first number and then added my 1. But why did I only add 4? Pause me and think about, or talk to somebody in your house about why did I do 96 plus 4 instead of 96 plus 5? So I added 96 plus 4 instead of 96 plus 5 like it says in my ones place. Because if I did 100 plus 40 plus 5, that would equal 145. I did plus 4 because if I knew if I added 96 plus 4, that would equal 100. So I got to a friendly number. Where did 141 come from? Pause me and think about where I got 141. I got 141 because I already used 4 of my 5 in the ones place. So then I had to still show that other 1 that I hadn't used yet. So then I did 141 plus the 100 from here, which equals 241 pennies. So far they've raised $2.41. Do you think that I can do the same sort of idea with other problems? Do you think that just how I only used 4 ones instead of all 5 ones to get to 100, so my friendly number, but then remember I still have one more 1 that I need to add up. Do you think that I can, with other problems, find my friendly number by breaking apart my ones place, my tens place, and my hundreds place? Pause me and think about if I can do the same sort of idea of breaking up my tens, hundreds, and ones places to get to friendly numbers in other equations. So what I just did is, all I did is I made it easier for myself because I found an easy 100 to round and regroup. But let's think about the equation. Does 96 plus 145 equal 100 plus 141? Remember, when I have an equal sign between two equations, that means that they're the same on both sides. Does 96 plus 145 equal the same thing that 100 plus 141 equal to? Pause me and think about it. What I asked is 96 plus 145 sum the same as 100 plus 141 sum? Are they equal on both sides? So some of you may have said that if you add 4 to one number, like how you added 96 plus 4, that's fine as long as you took away 4 from the other number. So if I added, right here, this is 96 plus 4, but then all I did was 145 minus 4 to make it equal. So I'm adding 4 to here, but taking away 4 from here to make it equal on both sides. So if you add a certain amount to one of the numbers and subtract the same amount from the other number, the sum's going to stay the same. So let's think about a conjecture we can make. Remember, a conjecture, I want you to say the word conjecture out loud. Say the word conjecture. A conjecture is a statement that we think about but hasn't been proved. So we can't say it's a rule because we don't know if it's true just yet. So I want you to think about a conjecture or think about a possible rule that we have to prove of what we just showed. If we add the same on one side, but we have to take away the same, and then the sum will still equal the same thing. Think about what a rule is that we can try to prove, a conjecture. Pause me now and think about a conjecture we could make to prove this. So a possible conjecture that you could have come up with, a rule that we're going to try to prove, is that if you add a certain amount to one number in a problem, that means you also need to take away from a different part of the problem. So if we put that all together, if you add a certain amount to one addend, remember an addend is just one of the numbers that you're adding up, so 96 is an addend. So if you add a certain amount to one addend and subtract the same amount to the other addend, add a certain amount, so like how we added 4 to 96, and then subtract the same amount, so like how we subtracted 4 from 145, so our other addend, the sum stays the same. So what I wrote is if you add a certain amount to one addend and subtract the same amount to the other addend, the sum stays the same. So we added 4 to 96, but then took away 4 from 145. So we added the same amount from one addend, and then we also subtracted the same amount from a different addend. And by doing that, the sum stays the same. So that's a conjecture that we're going to try to figure out and see if it's true. So in the next activity, we're going to be working to see if this conjecture is true for any addition problem, no matter what numbers we start with. What we're going to do now is we're going to try to figure out if our conjecture is true, if it can be proven true. So our conjecture was that if you add a certain amount to one addend and subtract the same amount from the other addend, the sum will stay the same. So what I want you to do now is just think about what 88 plus 105 equals 90 plus 103. Pause me and think about what you notice about this equation. What I want you to do, by either trying to solve this equation or coming up with your own equation, try to figure out if you can prove that this statement is true. So what I see here is that 88 plus 105 equals 90 plus 103. So what I see here is that 88 plus 2 is 90, and 105 minus 2 is 103. So what I'm going to do is I'm going to figure out if these equations have the same sum. So if I did 88 plus 105 on a number line, I'm going to first add 100 and then add 5. 88 plus 100 would be 188, and then plus 2 to get to that friendly number is 190, plus 3, because 2 plus 3 is 5. 190 plus 3 is 193. Now I'm going to try to do the same thing with my second equation, which is 90 plus 103. So that'd be 100 plus 3. So 90 plus 100 is 190, plus 3 is 193. So I notice that I have the same sum for both problems. What I want you to do is figure out a different equation that either proves that this conjecture is true, or find one that proves that it isn't true. With different equations, try to figure out if you can add one number to one addend and take away from a different addend to still get the same sum. So I'm going to try to figure this out with a different equation and see if our conjecture is true. So I'm thinking of 96 plus 145 equals 106 plus 135. So pause me and think about what I just did to change this equation to get to this equation. I added 10 to 96, and then I took away 10 from 145. Pause me and try to figure out if these equations have the same sum. So for my first equation for 96 plus 145, I'm making a number line, and I'm going to start with 145 since that's my bigger number. So if I'm adding first 90 and then 6. So 145 plus 90, 145 plus 90 would be 145 plus 10, so 155, 165, 175, 185, 195, 205, 215, 225, 235, and now I'm going to add 6. First I'm going to add 5 to get to 240, and then 1, because 5 plus 1 is 6, to get to 241. Now let's think of my second equation and figure out if they have the same sum, even though we changed up how we added it. So I'm going to start with my bigger number, so 135. I'm breaking down 100 plus 6. So now I'm going to add 100 to get to 235. And now I need to add my 6. So 235 plus 6 would be 241. So I see again, they have the same sum. So even though I changed this equation, it had the same sum because I added 10 here to take away 10. And I noticed that it was a lot easier for me to figure out what 135 plus 100 was versus 145 plus 90. But again, I still got the same answer because I just started with 10 less, but added 10 more. So I'm starting to realize that my conjecture is true. As long as I'm adding the same amount as I'm subtracting from a different add-in, I'm still going to get the same sum. So let's think about the equation 96 plus 114. How can I make this equation easier for me to add by taking away some from one add-in and giving the same amount to a different add-in? Pause me and think about how I can change this equation and still make it equal. What I see here is that I have 4 ones in 114 and 6 ones in 96. I know that 4 plus 6 equals 10. So if I was to think, if I took these 4 ones and put them into 96, 96 plus 4 would be equal to 100. So I took away those 4 ones and added them here. So then I would need to add 110. So what I did is I made 96 plus 4 equals 100, but then 114 minus 4 is equal to 110. And what we figured out is that as long as I'm adding the same to one add-in, as I'm taking away from a different add-in, my sum will still be the same. So I changed this because I knew that adding from 100 would be a lot easier than adding from a 96. So let's check to make sure that this is true, that these equations are still equal to each other. So if I was to do the first one, which was 96 plus 114, I'm going to start with 114, then add 90, then add 6. 114 plus 90 would be 124, 134, 144, 154, 164, 174, 184, 194, 204, plus 6, which would be 210. And then my second equation was 110 plus 100, which is equal to 210. So my second equation equaled the same thing, it just made it super easy for me to solve. So let's take a look at your have to today, which is also working on balancing your equations and making sure that they're the same on both sides. Your have to today is to work on IXL for 30 minutes on balance addition equations up to 3 digits for at least 30 minutes or until you get a SMART score of 80%. So that IXL skill is C.5, balance addition equations up to 3 digits. So it's asking you basically what our conjecture was before. If I added some or a certain number to one addend and then took away the same number to the other addend, what would make the equation true? So if 170 plus 2 equals 171 plus what, I see that they added 1 to 171. So that would mean that I would have to take away the same amount from 2. So if you add 1 from 170 to 171, that means you need to take away 1 from 2. So 2 minus 1 is 1. Let's give another example. So 669 plus 6 equals what plus 7? So I see they added 1. 6 plus 1 equals 7. That means I need to take away from 669 to make it balanced. So 6 plus 1 equals 7. That means I need to do the same amount but take away from the other addend. So 669 minus 1 is 668. Your have-to today is that you need to do 30 minutes of IXL on only this skill, and that is C.5, balance addition equations up to 3 digits. It's right here under the addition section. And in order to get a 3, you need to work on this IXL skill for 30 minutes or until you get a SMART score of 80% or higher.